You may also run across some quotient rule problems involving trig. Okay, so what I want you to notice about this one is that it is a quotient rule. Now there are some other ways to do it as well. You could rewrite it using your trig identities back from trig class. I'm going to use the quotient rule, but just know that there are other ways that this one could possibly be worked. Since it is a quotient, I'm going to use low d high and high d low, all that good stuff. So I have a high function. So that'll be the derivative of the high function, and then I have a low function, and then of course I'll have the derivative of the low function. So my high function is 1 minus cosine x, and my low function is sine x. Okay, the derivative of 1 is just 0, and the derivative of cosine is negative sine. So taking this derivative, you would have the negative of negative sine x, which would actually make this d high a positive sine x. Let's talk about those SIGNs one more time. You have a negative here, so that's where that one works out. And remember that the derivative of cosine is negative sine, so two negatives would make a positive sign there. Okay, looking at the bottom one, you have sine x. The derivative of sine is just plain cosine. And that's how that part would look. Okay, so then we're going to take our derivative. Remember the way that I talked about it was it goes low, always start low, d high minus high d low over low squared. Okay, so my low function is sine x. D high is sine x. Minus, because minus is what is in the formula. My high function is 1 minus cosine x, and d low is cosine x. Don't forget your denominator, it's over low squared. So that would be sine squared. Okay, and that's what we would get. Now let's simplify this. So when I simplify this one, I have sine times sine, so that would be sine squared of x. Now, my next part, I have a minus, and then I have something that I'm going to multiply out over here. So if I distribute this cosine through, I get cosine x minus cosine squared x. Okay, that's what I get when I distribute that. And of course that's over sine of x squared. Let's take care of that negative in the top. We have sine squared of x minus cosine of x plus cosine squared of x, because I distributed that negative, and that's all over sine squared of x. Now then, we need to simplify. Back in trig days, quite some time ago, you had a fact that sine squared of x plus cosine squared of x equaled the value 1, a Pythagorean identity. I don't expect you to know all of your trig identities, but sine squared plus cosine squared equals 1 is one that I expect you to know. So if you look at this top portion right here, sine squared plus cosine squared equals 1. So what I would get on the top was the 1. That 1 came from the green blob there, for lack of a better word. Sine squared plus cosine squared is 1. What's left on the top after that is minus cosine of x, and that's going to be over sine squared of x. And that's what your answer for that one would look like. Now I wrote my sine squared of x pretty funny. That answer right there in the red box is correct, but you could also have written it as 1 minus cosine x over sine squared. It also has the same notation here. So whichever sine squared notation that you're familiar with is great. Just make sure you don't square the angle, don't square the x. So either leave the whole thing in parentheses, or you can write the 2 behind the n. Okay, so that's how the quotient rule would work with trig. Let's do one more product rule. So I recognize this one to be a product rule. Here's my function 1, and here's my function 2. Okay, so function 1 is 2x. The derivative of 2x is just 2. Function 2 is cosine x. The derivative of cosine x is negative sine x. If I plug that in, I get function 1 times the derivative of the second plus function 2 times the derivative of the first. Now let's clean this one up. I'm going to bring my negative out in front, so this would be negative 2x sine x. I'll bring my 2 out in front, that would just be 2 cosine x. It doesn't simplify, it doesn't have any common factors other than 2. So I would say that that's a very good answer. If you did want to factor out a 2, you could certainly do so. Taking out just a 2, you would get negative x sine x plus cosine x. That would also be a correct answer if you put it in the factored form. One of the things I want to make sure that I stress is this x right here and this x here are not in the same position, so make sure that you never multiply an angle by an expression that's outside. The x here that I've labeled in a yellow color, that is the angle, and that's protected. You can't multiply the angle.